Hi guys, welcome to Introduction of Machine Learning, and this video will give you a great overview of all the categories of machine learning. Without wasting any time, let's get started. But just a quick reminder to please subscribe and share this video with your friends. It would mean so much to me. Before we get into the details of machine learning, it is very important that you understand the difference between AI and ML. A lot of people use these terms interchangeably, but they are not same, and you should understand the difference between them. AI, artificial intelligence. From the name itself, let's try to understand. It is about artificially building softwares that are intelligent like humans. Basically, any software that can be intelligent like human is AI. Should be able to think like a human, understand like a human, reason like a human, act like a human, make decisions like a human. So for example, your voice assistants, Alexa, Siri, your chatbots, or when you're playing chess, the online chess game, they act like humans and play with you, right? This is all AI. What is machine learning then? Machine learning is a subset of AI. It helps us in achieving them. See, we want our systems to be intelligent like humans. We want them to act like humans. In order to achieve that, do you think we write all the code behind it? We write down all the rules that if this happens, this is exactly what you should do. Do you think this is how voice assistants work like Alexa or Siri? No, right? There is so much of unpredictability involved. There is so much of ambiguity, complexity of data, the volume of data, the scale is huge. So what is the solution? Basically, you want to make your machines smart enough. So what do? We make them learn from all the data that we already have. That is exactly what is machine learning. Let me repeat that in very simple terms. Machine learning is about making your machines learn from all the data that you already have to achieve AI, to make them act like humans, to make them intelligent like humans. I hope the difference is now completely clear. Coming to categories of machine learning, there are mainly 3 categories or types of machine learning, and we will be talking about each of them in a lot of detail. But before that, let me get started with a quick overview of all 3 of them so that you have a upper level, higher understanding of the major differences between them, and then we'll get into details. The first type of machine learning is quite simple. It is basically about predicting an output based on some input. Sounds very simple, right? Like when you're doing weather forecasting or when you are trying to predict sales in Amazon or Walmart. So what do you have? You must have had some input, which would be some factors based on which you would have seen that these are the outputs in the past. Now for a new input, like for tomorrow, what is going to be the weather? Or for tomorrow, what is going to be the sales? So you're predicting the output based on some input. You already had some input output and you are learning the relationship between that input output and you're predicting the output for this new input. I hope you have understood. Let me give you more examples. Like for example, you had a lot of data where you knew that this particular post has a positive sentiment, this particular post has a negative sentiment, this particular post has a neutral sentiment. So here you're doing sentiment analysis. Based on some inputs, you are learning the relationship between that input and the output. Now, when a new post or text is going to come, you will be able to predict that what is the sentiment in this post or text. So what you're doing, based on some last input output, you are trying to map a function from that input to output. You are learning to do that, or you are building a relationship between that input output to be able to predict output for a new input. Like for example, there are a lot of mails that you're getting. Now you have the input output that this mail is a spam, this mail is not a spam, this mail is not a spam, this mail is a spam. Now when you get a new mail, when you get a new input, you will be able to predict that what is the output. Is this spam or this is not spam? This is called supervised learning, when you are trying to predict an output from some input. Before we move ahead, I would just like to take a moment over here to share something with you. Over the last few months, I think all of us have realized that ML/AI is the future, and that is why you're watching the video. It makes sense to read about it, to study it, and be future ready. And I've been doing the same. Over the last few months, I've spent so much time on ML/AI. In fact, we have a product called Taxstop, which is currently live only for the Educosys students, but we are integrating a lot of AI stuff into it, and I'm learning so much over there. Also, we have been designing a live hands-on generative AI course. We have finally launched it. It's a 7 weeks course. You can check out the curriculum over here. It has 10 projects, some small, some quite big projects, but it is going to be completely live, and I'm just so much excited for it because here you will not only be learning about generative AI, you'll be building, deploying and applying generative AI. The last hands-on course that we did was hands-on high-level system design course, which we call HHLD. That was MERN plus DevOps plus HLD. That is still one of the most enrolled courses on Educosys. I have seen so many students not only develop end-to-end projects, scalable projects, but deploy them and add them to their resume. It was one of the most satisfying things that I have done as part of Educosys, as a software engineer, as a teacher. That's when I decided that I want to do more hands-on courses, and I'm really excited for this, and it's going to be live, so I hope to see you there. Like all the other courses, you will get access to the recordings, to all the future live batches, and you will get the access to code, notes, everything. You can check out the details, you can check out the testimonials of all the other courses, and I'm really excited for this. But for now, let's continue. I hope to see you there. For now, let's continue. In the second category of machine learning, there is no exact output that we are predicting. The first category was supervised learning. We had a specific output that we were trying to predict. In the second category, which is called unsupervised learning, there is no exact output that we are predicting. So what exactly are we doing? So if we have a lot of data, we are trying to find any pattern that we can find. Any groupings, similarities, relationships, anything you can find in the data, that is what you are trying to do in unsupervised learning. Let me give you some examples. For example, if you have a lot of images, your model can group some similar images together. For example, if you have a lot of cat photos, it is going to group all of these photos together. It is going to group all the dog photos together. Similarly, we could do customer segregation. Basically, we could group similar customers together. Customers of similar age, income, spending habits could be grouped together. Or you could find patterns, like if bread is bought, butter is tend to be bought, right? So you could group these patterns, you could find these patterns in your data. Or you could find recommendations, like if these movies are watched, then you could recommend these movies because they are of similar types. So you can group those movies together. Or in social media, what topics are currently trending? You could find patterns or you could find groupings. So all of this comes under unsupervised learning. The third category of machine learning is called reinforcement learning. It completely focuses on learning based on some feedback. For example, in Netflix recommendation system, you must have seen, do you like the recommendation of this movie or do you not like it? Similarly, you must have seen on YouTube, Insta, you must have seen on ChatGPT that do you like this answer or do you like this answer? What is happening over here? The model is becoming better at decision-making skills based on interaction with the surroundings. This is called reinforcement learning. What does reinforcement mean in English? If you search it, it just means becoming stronger. So you are becoming better at giving results based on some feedback. Now, feedback can be positive or negative. So if there is positive feedback, you have rewards. If there is negative feedback, you have penalties. So what is the outcome that you want? You want to maximize your rewards. So this is called reinforcement learning. The entire learning process is basically based on trial and error, and the entire thing becomes better based on the feedback that you receive. Summarizing all the three categories in short, in supervised learning, we have input output and we try to find relationship between them to predict output for the new inputs. In unsupervised learning, we find similarities, patterns, groupings between the data. There is no specific output that we are looking for. In reinforcement learning, we are learning based on feedback. So it is all based on trial and error. And what is the goal? To maximize our rewards. So I hope the differences are clear. And now let's start discussing each of them in a lot more detail. Let's get started with discussing supervised learning in a lot of detail. What did we understand so far? We have input output and we understand the relationship between them so that we can predict the output for the new inputs that we are going to get. Now things are going to get a bit more interesting over here, a bit tricky, so stay with me for 2 minutes and I promise it will definitely be clear. See, the output can also be of various types. For example, the output can be specific numerical value or it can be categories, some predefined classes that you decide. Now these are the two types or categories of supervised learning. One is called regression and the other is called classification. We are going to take a lot of examples, it is going to be clearer. But I know the question that must be coming right now is that what is the difference between classification and unsupervised learning? In unsupervised learning also we classify data, we group data based on some similarities. Here also I am talking about categories only. The difference is that supervised learning as general is about specific outputs, right? So in regression, it is specific numerical value. In classification, we have some predefined categories into which we are going to classify. See, in unsupervised learning, there is no specific category. We are just finding similarities. There is no specific output. Versus in classification, we already know the classes into which we are going to categorize. So the output is there, just that there are fixed number of classes into which you can categorize it. So firstly, I hope the difference between classification and unsupervised learning is completely clear. As a simple rule, just remember that in supervised learning, you have a specific output. In unsupervised learning, there is no specific output that you're looking for. You're going to find patterns or groupings that you don't know of from earlier itself, right? Let's discuss a lot of examples so that things are completely clear. All the examples that I'm going to be talking about right now are for supervised learning. We are just understanding regression versus classification in detail. I've noted down a lot of examples. Let's go through them one by one. If we talk about house pricing, if we are going to predict the exact price of the house, whether it's in rupees or dollars, it's a numerical value. So it's a regression problem. Versus if you're just predicting that the house is going to belong to which category, you're just classifying it into affordable, mid-range, luxury or uber luxury category, then it is a classification problem. The categories, you already know them, you're just classifying them into one of the categories. Similarly, in weather prediction, if you're predicting the exact temperature that is going to be tomorrow, like in degrees Celsius, it's an exact numerical value, it will be a regression problem. Versus if you're just predicting whether it is going to be sunny, rainy, cloudy, it is a classification problem. In exam performance, if we are predicting the exact marks that a student is going to get, say out of 100, this is the numerical value, then it is a regression problem. Versus if you are just predicting whether the student is going to pass or fail, it is a classification problem. Similarly, in stock market, if you're predicting the stock price of a company in numbers, in rupees, dollars, then it is a regression problem. Versus if you're predicting whether the stock value is just going to go up or is it going to go down, it is a classification problem. In health monitoring, if you're predicting a person's exact blood sugar level, then it is a regression problem. It's a number that you're predicting. Versus if you're just predicting whether the person is diabetic or non-diabetic, it is a classification problem. In e-commerce like Amazon, if you're predicting the exact amount a customer is going to spend on the website, then you're predicting exact number, so it's a regression problem. Versus if you're just predicting whether the customer is going to make a purchase or not, it is a classification problem. In sports, if you're predicting the exact number of goals that a player is going to score, like in football, then it is a regression problem. Versus if you're just going to predict that the number of goals is going to be low, medium or high, it is a classification problem. I think these are a lot of examples, and now the difference between regression and classification should be quite clear. Also, since you're learning machine learning now, it is time that you get started with using the proper terminology of machine learning. So the inputs that are sent to the machine learning model, the inputs that we have been talking about, are called features. These are the characteristics of the inputs that are used to make the predictions. These are also called independent variables because these are not dependent on anyone. These are the ones that are going to be used to make the predictions. So your inputs are also called features or independent variables. And the outputs are also called labels because that is a label that you're putting, right? So outputs are also called labels. These are your target values or your results that you're trying to predict. These are also called dependent variables because these are dependent on your inputs. So in short, inputs are also called features or independent variables, and your outputs are also called labels or dependent variables. So I hope these terms are clear, and this is what we'll be using from so on. Coming back to supervised learning, where we have to find a relationship between input and output, there are many algorithms for the same. We are not diving into algos because this is an introduction video, but you should know that there are many algos for both regression and classification. For example, in regression, there is linear regression where obviously, as the name suggests, there is a linear mapping between input and output or between independent and dependent variables. Similarly, there is polynomial regression where there is a polynomial relationship. There is logistic regression, there is ridge regression, there is decision tree regression. There are many other algorithms. Quick summary, within machine learning, there are three types of learning: supervised, unsupervised, reinforcement. We are talking about supervised learning, within which we talked about regression and classification. Now, there are many algorithms for both, but also within classification, there are three types. Don't get overwhelmed. These are very simple. See, basically, this depends on the number of classes or categories that you're dividing your data into. It's very simple. If you are dividing your data into two categories or two classes, you are going to call it binary classification. If you are classifying your data into three or more classes or categories, you're going to call it multi-classification. Not hard, right? Similarly, what you could also do is put multiple labels to a particular data. What are labels? Your outputs. So in classification, what do? We put label or a category to a particular input, right? So to a particular data or a particular instance in your data set, if you are putting multiple labels to it, then it is called multi-label classification. So there are three types of classifications: binary, multi-class and multi-label. It's time to now move on to unsupervised learning. What did we discuss earlier? In unsupervised learning, there is no target or output. So that is why in unsupervised learning, we train our models using non-labeled data or unlabeled data. This is the key difference and this is very important. Listen very carefully. In supervised learning, we have input and output, right? Or we have features and labels. But here in unsupervised learning, there are no outputs. So our data, our features that we have is there. Our input is there, features is there, but there are no labels attached to them. There is no output attached to the input, right? So the data is called unlabeled data because there are no labels associated with them. So again, in short, in supervised learning, there are features and labels. So there is label associated with all the features. There is dependent, independent variable. Versus in unsupervised learning, we have unlabeled data. So there are features, there is data, but there are no output for that data. We are trying to predict something that we don't know of. We don't know what is going to be the output. We just have to figure out a pattern or some relationship or some similarity in the data. Unsupervised learning can again be divided into three major types. Don't worry, we are going to understand them in very simple way. If you think about relationship in data, what is the simplest relationship that you can find? You can group similar data points together. So what are you going to do? You have a lot of data points. So you're just going to see that, okay, these data points have similar features. We are going to group them together, or we are going to cluster them. So this first type is called clustering. Very simple, right? Let's take a lot of examples. For example, customers who tend to buy similar products, we are going to cluster them together, group them together for targeted marketing. Or if we have a lot of news articles, a lot of documents, we are going to subgroup them. How? The articles that are related to politics, that are related to tech, entertainment, sports, and so on, right? So we are clustering our data points. Or similarly, the example that we took earlier, if we have a lot of images, we can cluster the images that look like cats. So cat images, we can cluster dog images. So these are all examples of clustering, which is the first type of unsupervised learning. In order to understand the second type of unsupervised learning, let's discuss something. A lot of times the data that we have might be very, very complex. We might have a lot of features or variables that are involved to each data point. For example, if we are storing customer information, we might be storing a lot of features or variables that are very redundant or very irrelevant. Let's take example. Suppose for a customer, we are storing age and date of birth. Redundant information. We are storing monthly income and annual income. Redundant information. Do we need to store both? No. Now see, the more features or dimensions or variables that we are adding to our model, we are going to need more computation power. Our training is going to take more time. Our system is going to become more and more inefficient. Now, a lot of these variables are not important, right? Firstly, redundant information we should definitely be removing. A lot of information is also very irrelevant. A lot of features or variables or dimensions are irrelevant. For example, a customer's middle name or a customer's height might not really influence their preferences on social media, or their eye color, not really relevant, right? So in our second type, which is called dimensionality reduction, what we do is that for our data points, we are reducing the number of dimensions or features or variables while retaining the important information. So it is not like we are going to remove the important info, we are going to retain the important info, but we are removing the irrelevant, redundant features. Another example could be, suppose we have a very high resolution image, suppose 1000 by 1000 pixels. Now, if we consider each pixel as a dimension, then it has too many dimensions. Now, instead of that, if we just compress the image, more or less we will be able to train our model, but we will be able to reduce the dimensions a lot. Our system is going to become a lot more efficient, training is going to take a lot less time, and the computation is going to be a lot faster. So this is the second type, dimensionality reduction. So what are the two types that we have learned? First is clustering, where we group some data points together based on some common features or similarities. And the second one is dimensionality reduction, where we are reducing the number of dimensions of features. Now see, even though in clustering we are grouping the data points according to similar features, there might be a lot of cases where we might need exact relationship between the attributes. For example, if a customer is doing this, then they are likely to do this. This is the exact if-then relationship. So when you want exactly how the attributes are related or exactly how they are associated, and you want to mine out that association, that is what is called the third type of unsupervised learning, which is association mining. It is also called association rule learning because we are learning the rules for the association or the relationship. For example, if a customer is buying bread, they are likely to buy butter. This is a simple classical example of if-then rule or if-then association. If a customer is doing something, they are likely to do something else. If a customer is buying a phone, they are likely to buy phone cover. If a customer is, say, opening a savings account, they are likely to get credit card. If a viewer has watched the video till here, they are likely to subscribe and check out the curriculum and enroll for Generative AI course. See what I did there? A simple relationship, if-then situation or if-then association or if-then rule. By the way, again, since this is an introduction video, we are not going into the details of algorithms, but there are common algorithms for each of these types, just naming a few for the introduction. For clustering, there are many algorithms like k-means, hierarchical clustering, there is Gaussian mixture models. For dimensionality reduction, there is PCA, LDA. For association mining, there is FP growth, there is a priori algorithm. There are many other algorithms out there. This is an introduction video, so you're just getting started, don't get worried about it. Okay, so I know that this might be a lot of information to take in. So a good news is that reinforcement learning doesn't have any major types like unsupervised and supervised learning. It is just good enough to know to get started for the introduction that it just focuses on maximizing rewards and it focuses on interaction with an external environment, like the examples that we had taken earlier, recommendation system in Netflix or for example YouTube Shorts or Insta Reels. So it just focuses on getting feedback from an external system, and based on the feedback, it focuses and tries to maximize its rewards. Now that we have discussed the three categories of machine learning, it is time that I wanted to discuss the usual steps that are involved in machine learning. These steps apply to all three types: supervised, unsupervised, and reinforcement learning. These are the usual steps that will give you an idea of what exactly happens. So the first thing that we have to do is collect the data. So the first step is data collection. Whatever different resources are there, whether it is labeled, unlabeled, for supervised, unsupervised, that's fine. The first step is data collection. Then we pre-process the data. What does data pre-processing mean? If any data is missing or if we want to transform it to any particular format, so we do that. So we collect the data, we pre-process it. And once we have done that, we do feature selection. So we are selecting the features that we are going to be using, and then we are going to select the model. So we will be using the model that we will be using to train. And then we finally train our model. So once we have trained the model, also there are a lot of steps involved. We have to evaluate whether our model is doing fine or not. We have to test it, validate it. If anything is required, then we tune it. And after all of this, we finally deploy it. After deploy, we monitor it. So these are the usual steps that are involved. Before we wrap up the video, there are just two more terms that I quickly wanted to cover because these terms are heavily used. One is deep learning. See, deep learning is a subset of machine learning. It uses artificial neural networks which are inspired by how human brains work. So deep learning, subset of machine learning only. Okay. Generative AI is different. From the name itself, it is used for generating new content. So any new text, new images, it does not do any prediction or classifications. It generates new content. So generative AI. And you'll be getting hands-on experience of generative AI in the hands-on generative AI course. So do check out the details and enroll if interested. But if I watched it here, hopefully you love the video, and please do subscribe, share with your friends. It would mean just so much to me. And I promise I'll be a lot more regular and a lot more free content coming up. So please do show your support and see you next time. Bye.